Hello everyone, it's June 16th. Alright, first things first, we're gonna get back to this one. So we're gonna try to solve it using the other method, the Monachis algorithm. So let's go for that one first. Then we're gonna try to solve today's challenge. And then the last, if we still have time, we're gonna go to deal with that one that's been troubled us for 3 nights. Alright, Monachis algorithm. So we read about it yesterday, and I tried to figure it out myself without going read it again. So basically we say, if we find, we first insert. We insert a separator, and then we're gonna have the previous center and the previous reach. And if the next one is outside the reach, then we're gonna start with 0, right? No, start with either 1 or 0. Well, if it's a separator, that's gonna be 0. But if it's not a separator, it's gonna be 1. And then we start going out. That's if it's outside. If it's outside, then we don't have any information. We should have to start from start. But if it's inside, right? If I'm inside a right reach, that means I am either, right? That means I'm either then we're gonna find the mirror image, right? So either this or this. Yes. Okay, so we're gonna say s underscore go to this dot join. That was a trick that we learned. Plus s plus doesn't matter this, right? So this is our new thing. And dp is going to be, say, 0 times ln s, right? Now, when it says center and reach, we start from 0 and 0, right? And then we're gonna go start from, say, for I in range 1 to ln s, okay? Now for each one, we have a few choices, right? We say if let me say a temp, right? We'll say if I is outside C plus R, okay? So it's outside the reach. If it's outside the reach, then if it's inside the reach, then we have a little bit. If it's inside, then we have a little bit mirror, right? We can mirror this same as this one, and then we will extend as much. Take the smaller one, right? So if it's outside, this is outside, then we say temp equal to 1 equal to 0 if si is equal to a separator, else give me 1. Else, so it's inside, right? So I'm inside the reach, then temp equal to minimum. Either I mirror image it, and the way we do mirror image is this is the center, we're gonna double the center, right? We double the center and then minus I. So either dp 2 times c minus I here, double the center. We'll move here, and then we minus I. Will give us this. So that's that. Or the right reach. Oh, maybe no. The right reach we don't have to C plus R, just R. And the right reach minus R is minus I. That's the number on the right side. So we have the temp, right? And then we say while we can have a j, right? J equals 1. So while to the right and to the left. Shouldn't that just be I plus j and I minus j, right? Oh no, we have a temp. Temp is the reach. Temp is reach, so this doesn't matter. The reach is 0. We'll just stay where we are. Otherwise, the temp is the reach. So from I, how many we can reach? So it's going to be I plus temp, right? Wait, come on. What is the reach? Now, the reach is reach the index of the. I guess it doesn't matter what the reach is, right? The reach can be just the index on the right side. Okay, if the reach is just the index on the right side, yeah, the reach is just the index. But then this is not the index on the right side. This is not. This is a count. I don't like it. Let's just make it the count. So let's say the R is just from the center. 1, 2, like how many times we can go. So then this has to be C plus R, right? Center, that's R. So if I'm larger than that, then my current reach is 0. I don't have any reach. I just stay with myself. Otherwise, I say it's the mirror image, right? 2 times C and C minus I, or this shall be C plus R minus I, because I am smaller equal to C plus R. So that's the current reach. Okay, so then we start from the center, right? So from center, now I'm gonna reach out, and we say temp is current the reach. So I plus temp plus j, right? And then we say, well, s this is equal to s I minus temp minus j. So while these two are the same, and because we have these at the end, so we don't have to check. So while they're the same, then I don't have to. I think I just need to add temp. So So temp is the reach, right? Temp is the reach. Yeah, this is a situation where so the dp 2 times c minus I is the situation where the palindrome centered on I does not extend beyond c plus r. C plus r minus I is the situation where the palindrome centered on I extends beyond c plus r. If it extends beyond, then yeah. So we grab the temp. The temp only allows us to go from here, blah, 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 here. So we know these two are definitely good. So next one we say temp plus equal 1. And then once this, temp plus equal 1. Right? Until a point, it's not the same. Right? And then it's not the same. What do we do? Temp minus equal 1. Alright, so we extend until time is not the same. So temp minus equal 1. And then we want to find the maximum reach on the right side. Then we say if c plus r is smaller than I plus temp, then c r equals I temp. Right, we extend. So the whole thing we want is for the right reach to reach the maximum. Because if we have the maximum, then we can reduce the computation. And don't forget dp. Oh, we can actually do this. dp I shall equal to temp plus 1. And then this all can be dpi. And at the end, come out dpi minus equal. Oh my god, did you do, man? And then we run this, and here it's gonna be dpi. Okay, so once we're done, we just need to find the maximum, right? We need to find the maximum. We can actually go through. So you can have Yeah, I just write another code. Again, for I in range, I can say for I, let's call it D in dp, enumerate dp. And then we say index and max d. If d is larger than max d, index equals I, and then max d equals d. So we find a maximum, and then we need to return. So we know this, and we know how much it extends. All right. And use the example from yesterday. We have this B, A, B, A, D. Right. So if the index is on the ladder, then we maximum reach so the maximum reach can be on the separator. It will always be on a separator. So the maximum reach will always be on separator. So we need that one divided by 2. It works. Because if it's on separator, it will always be even number. Odd. It will always be odd. So divided by 2 works. So if it's on the separator, then yeah, so we divide by 2. So basically we can return S. So from I, right, minus D divided by 2. Okay, so 1, 2. Yeah, I think we just D divided by 2 to I plus D divided by 2. We probably need to plus 1 here. Okay, let's try this. It might look different. Index out of range. That is strange. Okay, why do you plus 1 here? Don't understand. Nope. I don't understand. Plus, we don't need a temp. I just realized. Like, why do you need temp? Just DPI. I shall do. Alright, we still out of range. Interesting. Maximum reach. This will be minus 1, right? don't understand. Let's run this. Yep, this is as expected. So what happened here? I don't know. Let's print dp I. Actually, I'm going to do dpi here. No, I plus dpi. One zero. 2 0. Wait, what? Oh, 1 0. 12 0. Oh, yeah, we can go to 12. Hold up. 12. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, we cannot go to the last one. My bad. Okay, so now we don't have this problem. We have a different problem. One problem at a time. Yeah, this algorithm is not an easy algorithm to do, so it's totally fine if we have this issue. Okay, so we're supposed to find this. So we have 2 3s, right? Okay, we have 2 3s. Oh, I. It should be index. And the max D. I have no idea why I do that. It's max D. Okay. Almost. We're almost there. So you're saying we need to -1 here. But why? We have the index, right? We have the maximum reach. And then we know it's going to be divided by 2. Right? So the maximum reach is 3. Divided by 2 is 1. So from... You notice, this is weird. Index. Oh, index is not right. Dude, index is not right. Index is also doubled. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The index is doubled. So the index need to divide by 2. Right? Index need to divide by 2. So we say an index need to divide by 2. ABA is fine. But I don't understand. 0, 1, 2, 3, 4, right? 4, 0, 1, 2, 3. Wait, isn't 0, 1, 2, 3, 4? What? Zero, 1, 2, 3, 4. Oh, wow, there's another one. I didn't see. Ah. color me blind. 0, 1, 2, 3, 4. And 4 divided by 2 is 2. There's supposed to be 1. Hi. I just got lucky. I was looking for this one. That's not right. Hold on. It's not just divided by 2. So we have this, and we have 3. So we go 1, 2, 3. So we can grab this, right? And on the right side, 1, 2, 3, I can grab this. So basically, we can grab these, and we can split and join. That's one way to go. So 0, 1, this is 1. 0, 1, 2, 3, 4, 5. So I think it should be minus 1 divided by 2. So I think, no, this is not right. So this minus 1 divided by 2. This apparently plus this minus 1 divided by 2. And now we don't use this. So from here, 1, 2, 3, we have this, right? And then minus 1 is 0, 1, 2, 3, 4, 5, 6. 6 divided by 3 is, 2 is 3. 0, 1, 2, 3. So go on the right side, we don't minus 1. Oh, we can minus 1. But after we minus 1, we will hit the actual thing. Yeah, we can go minus 1. Then we hit this, then we do plus 1. And then we already did we did minus 1 inside already. Hold on. We are at here. 1, 2, 3, 4. Right? 4 has 3 is 7. 5, 6, 7. So we're here. But I want to remove the start. So we are at 6. Right? 6 divided by 2 is 3. So we say we want a 0. So this corresponding to this. This corresponding to this. This corresponding to this. That's why we don't plus 1. Okay. This now makes sense. Let's do this. So this is the Monach's algorithm. It's not trivial. And it's not trivial and quite tricky for me. Okay, let's try this. We have enough test cases here to give us a good run for money. Man, I thought we hit a road bump. Do we have a better performance? 289, yeah, it's much better. I thought it's trivial, but it's actually not. It's a good problem, huh? Alright, finally. Alright, can take a look at this. We did this. Yeah, we forgot the minus 1 initially, and that cost us a lot of time. And this is fine. We did that, then we did. I think the R represents different things. In my current case, is the most on the right. it have to be C plus R, but in here it's just R. And so we have to +1 or -1. Put it inside, which is fine. And look at this. Oh, it's the same. Oh, PI is still just the amount. Then why don't you just make these two mean the same thing? Like here, R and then PI means different things. R is like the most right reach, but the DP is actually not. DP is the amount of distance added to the original index. So these two means different things. But in my current one, they do mean the same thing. Ah, me, can you max? Didn't. Yeah, this is how you're supposed to do it. And finally, this is so 3, right? We want to say 3 places that's tricky. This is the first place. You have to leave the one on the outside. Don't touch them. The second tricky is this far. Right, and the third tricky is the final return. I mean, we can just cop out and then we say we split on this and then we join again. But apparently this is better. Okay, so that's that, and this is how I want to see it. We're gonna go for discussion, but let's do the actual problem today. It's a hard problem. You ready for that? Given the root of a binary tree, we install cameras on the tree node, where each camera in the node can monitor its parent, itself, and its immediate children. Minimum number of cameras need to monitor all the nodes. That is an interesting question. That's a very interesting question. This one is 1, right? This one's 2. 1,000 nodes. Okay, let's think about it. Minimum cameras. So we're given a binary tree. I kind of want to draw a little interesting tree, right? And minimum cameras. How would you say? What if you know the minimum camera on the subtree? Usually this is how it goes, right? I am at a root. I want to know the minimum camera needed for my tree, right? I need to know. So if I know the minimum camera that's needed for my left subtree and the minimum camera needed for my right subtree, right? If I know that, if I know the minimum number of cameras on my left subtree, right? I say I know how many cameras there are. And I need to also know if the root has the camera. So 2 pieces of information to return: the minimum number and if the camera is on the root. If I know these 2 pieces of information on the left subtree, and if I know it on the right subtree, then I can make decision, right? So if both they don't have the root, then I need to add a 1 on my root, right? I need to add because I need to monitor the root. If one of them has, then I don't have to add 1 on my root. So, okay, what will be the edge case? Well, the edge case will be the leaf node, right? Then the leaf node will always have a camera, because on the leaf node, I will say, oh, well, I mean, I need to monitor myself, and I don't have any choice. So if I put a leaf node, I put a camera. Okay, so if I leaf node, I put a camera. Yeah, it's the most simple tree, just root left and right with a leaf node. And the leaf node, both leaf node will put a camera. Then I come back, and then I have both Now that's the problem, right? We suppose actually is the current node put a camera, and now I can cover the leaf node. That means the recursion relation is not correct. The leaf node, if we put a camera on the leaf node. Hold on, think about it again. Okay, think about this way. On each node, there's always going to be just two decisions, right? Either I have a camera or I don't have a camera. No, that's not dynamic. This should be dynamic programming. So yeah, in this case, right? If I know my child, this one has one camera and it's on the root, then I know, okay, that's it. So now the question is, how do I know the camera should be here instead of on the... I mean, I can set it as a rule for 3. It's always better to put the camera on the root instead of on the... I don't know. I don't have a good idea right now. That's 3. Nah, I would be like just traversing. I want to run some trials. Do we have a tree visualizer? We do. Okay, here's what I want to do. I want to go, say 0, 0, 0, and 0, 0, 0, 0, 0, 0, no, 0, no, no, 0, no, 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 no. Makes sense. Yeah. I don't know, I just not return anything. I just want to see how this one goes. Three cameras with this situation. I do. These two both don't do. So we say this one must be monitored. Then we have this one is not monitored. So we can either do it or don't do it. So okay, in here, we can choose not do it. But I don't have children. It's a leaf. So this one has to do it. And this one has to do it. This one don't do it. So that's 4. I can choose this one, don't do it. Right? And then one of them needs to do it. So I would choose this one to do it. And then if this one do it, then this one doesn't have to do it. And this one doesn't have to do it. Then this one has to do it. And so now we can choose this one to do it, and this one doesn't have to do it. Oh, this one don't do it, and this one has to do it. So 1, 2, 3. It doesn't feel right, you know? It just doesn't feel right. Path. Did you see that? Path. On a single path, always half of it. on a path. And if you think about in terms of a path, each path to the leaf, if it's even number, then even number of it has to get it. Half of it has to get it. If it's odd, it's also half. Integer division half. Interesting. I'm actually going to try to do it this way. So, because you're given a tree, I'm just trying to prove that this is actually makes sense. If you give me a tree, no matter what tree it is, right, and I go down a path, I can say for any path, right, for any path, the minimum possible way is always going to be divided by 2, right? You cannot do smaller than that. At least the first one you pick, right? The first path you pick, you have to do half. Right? If you do smaller than half, then it's not going to work. Now, what I'm afraid is there will be some situation where, let's see, let's do 5, right? 5 will require 2, but I say, no, I just want to do 1. Let's say I pick this one, and I don't pick any of these are the 3. Now, we need to, so in order for these to be observed, I mean, this one's observed here, so the first 2, right? So we will need 1 to observe these 2. But now I say, I don't want this 1, right? I don't want to use 1 to observe this 2. Or maybe you say, I want to use 1 because they are on a path, right? They're on a path. So for this one, it has to be, if it's because it's a binary tree, right? Yeah, it's a binary tree. So if the left, basically it's a parent and left, it's impossible, right? So the only possibility is for the right subtree, to light up. That's 2 right subtree. So like if we say we're on another path, this is both right subtree has to light up. Oh, that's actually correct. The lights up. The right subtree lights up. And 3. But hold on. What if we don't do it this way? What if we just do the regular way? We say, okay, that's 5. We need 2. That's 3. So we have to use these 2. Now we pick one path, right? And now we see this path of nothing, so we pick the middle. Now we see this path, we have this, we have this. So 1, 2, 3, 4. But we can actually do it with 3. Yep, I see the problem. Interesting. Right, I think I got it right. This will be 0, 0, 0, 0, 0, no, 0, and then 0, no, no, 0, and no, no. Right, and then 0, 1, 2, 3, 4, 5, 7, 8, 9. So a bunch of no's at the end. I don't even know how many no's. A lot. Let's just try this. If it's a yeah, that's the one. So it just be 1, 2, 3. It should be only 3. How did you know that? Yeah, this is a 3. How did you freaking know that? I don't know, man. Because if it's 1, you gotta do it. If it's 2, that's also 1, and it doesn't really matter which side, right? Also works. But if it's a 3, right? If from me, I know my my subtree, right, has 2. That means it's a 3 situation. It doesn't matter how, it's going to be a 3 situation. If we say if it's a 3 situation, it'll always be best to put it in the middle. Then all 3 can, then that's the situation for the subtree. And then I look at the other side, right? Okay, let's say, okay, then we put it here. Now coming into here, on the left we have 4, right? And then what we have is 4, and this one doesn't have anything. So this one is not. So if I'm by myself, then I have to take care of myself. But I have my right subtree, and the right subtree is 3, so we put in there. Okay, so I'm good. So back in here again. Do we have another situation? Our right subtree is this right subtree. So the right is only have 2, so it's okay. We put in 1. Done. I'm done. But I don't know. Now I don't know. So I just, my right subtree is 1, 2, 3, 4, 4. And I say, oh, it's too complicated. I keep going. So in here, Right subtree is 1, so we don't know yet. On my right subtree is 3, so I say, okay, I want to put 1 here. Okay, so because this one is 3, so I'll put 1 here. And if I put 1 here, I got covered, right? But this one is not covered. So I have to cover this one. Right, I got covered. This one doesn't get covered. So it's 2, which means it's a toss-up. It doesn't really matter, right? And then the other side is it's a 2. Well, we can say if it's a 2, then always this one get. Okay, so in here, okay, because it's 2, I say always this one get. So it's this one, and this is get covered. So it's 2, so always this one get covered. So that's 3. I don't feel confident. I feel this method is not going to work on some random tree. I mean, it works for these, but always go for that. It doesn't feel right to me. It doesn't feel right to me. That does not. Oh man. Do you have any hints? Dynamic programming. It should be DP. How do we DP this? How do I DP this? It shall be the minimum, right? The minimum number of trees, not number of cameras in a subtree. Like I said, if I know the minimum number of cameras in a subtree, so I have this subtree and this subtree, right? Say if I know the minimum camera in this subtree, and know the minimum camera in this subtree, then also depends if the camera is on the root, then I don't have to get one. Then we have the minimum. It makes sense, right? Okay, so another question: the minimum camera in this subtree. Okay, then we don't know is the minimum camera in this subtree. It's going to be 1, and I have to take it. Now that's the problem. I have to take it. Now I come back up, right? I come back up. I say I don't have the left subtree. I have a right subtree. It tells me the minimum is 1, and the camera is here. So I say, okay, I don't want 1, right? Because it's already done. So I don't want 1. So that is the leaf taking the camera. Right? We shall also say the leaf can not take the camera. Yeah, like as easy as just a 3, right? So okay, we don't know the left subtree and the right subtree. And then the left subtree is an empty node. Is one node. Is the leaf. Okay? Is the leaf. If the leaf node, I say I don't know. I can or I cannot. Or we say we always not put on the leaf. Yeah, I think that's the rule. We should not put on a leaf. Because if we put on a leaf is a kind of waste. Right? We always not put on a leaf. So I say if it's a leaf node, we always don't put on a leaf. Now, so if it's a leaf node, we just return. Except with only one camera. Now we just return. Right, nothing. So we return with 0 camera, and that's not. And in this case, okay, I'll put it here. So that's that. So in this case, okay, I'll put here. So leaf node always don't return. Okay, so now that's the right. How about the left subtree? The left subtree over here. Now we go right. Same thing. It would be here. Here, so it's gonna be the subtree of this. And for this, we don't have the right tree, so the left tree. So the subtree of this. Right, leaf node doesn't have, so it will have to be here. Right. So now this one return says I don't have one. Like I have one camera, but it's not on me. And this says I have one camera and it is on me. So this says I have 2 cameras, it's not on me. So maybe. How about the other example? I see this example. So here we will do this. Here, so this one is nothing. So that doesn't return a camera. So I will do here. Here, this one will return a camera. Right? So this one will return a camera. So here, this one's cut. So this one has nothing. So oh, this is also 2. Wait, hold on. Is it 2, right? Man, gotta redo this. 0, 0, 0, 0, 0. No, 0. No. No. 0. No. I think it's 4. No. 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 Yeah, that should be 2. Which is this and this. It ain't 2. It's 3. Because this one's empty. This one returned nothing. It's a leaf node. It's a leaf node. Return. Shall return -1. Right? If it's a leaf node, return -1. I know it's a leaf node. Then this one must have. That's the rule. So we don't put on leaf node, we always put on here. Because for these, this is the same, and it's always more beneficial to put on here. Because you put a leaf node, it's only benefiting one node. If you put it here, you can benefit in more nodes. So it's okay, always put on this node. Okay, so this one, I see -1, I have to put it here. And for these 2, we'll put on here. Right, so we kind of wasted, but we kind of have to. I mean, let me try. Let me try this. How long have we been dealing with this? Oh, we have to deal with this because this is today's challenge. So it might work, might not work, I'm not sure. So what do we do? Should realize that's actually not DP, that's just that's not DP, man. Because I'm not repeatedly calling those things, I'm only calling them once. Hold on, let me think. Hear anything. Where does DP come from? This is like more like a greedy, right? We always not color. We always not color the leaf node. Hold on, let me think again. I think about states, right? How many states do we have? So each camera is either, not each camera, each node is either monitored or not monitored, or have a camera on or not have a camera on. So it's like 4 different states. Well, if we have camera on, that's actually is always on. So 3 states. We have camera on, and it's being monitored. Camera not on, it's being monitored. And camera not on, it's not being monitored. And the function we're trying to see is the root camera not on. Actually, we don't know. It should be camera on and monitored, and camera not on, not monitored. Right? So, because that's how it is. We can put a camera on, or we can don't put a camera on. Yeah. So for the root is we put a camera on, right? Or we don't put a camera on, and it's not monitored. And in that situation, Okay. So we say we can put, so we have a node and we have camera on and monitored. Well, that's what we can do initially. And then we call this function. Now we go to the child functions, right? And the child functions, so the left subtree, when we call it, we can say, because it's camera on, we can also call it. So we can call it also camera on monitored, or camera not on, but it's also monitored, right? So it was two state, and we can try to find the best. Okay, and then this one, if the camera on, then we come and we call this one, right? And then we call it the next one. So when we call that one, we can do camera on, and of course it's monitored. Okay, and this is the leaf node, and we see the camera is on, then we return 1. And we also can call it camera off, but it is monitored. So with no camera, but it's monitored, so we can return 0. So this one shall give us 0 on the left subtree. Okay, so that's that, and then we remember, and on the right side, same thing. We can call camera on, camera not on. Okay, we can also call camera not on. Yeah, so for each run, we can always put a camera on, right? We can put camera on all of them. So again, let me think. So if the root, the camera is on, then when I call my children, there are two situations, either camera on or camera off, and in both situations, they are being monitored. If I do not have camera on, even if I am monitored, right, then when I call my children, and then they can be camera on or camera off, but when they get the camera off, they will not be monitored. So like the initial state is they are not being monitored. Maybe this is a better way to handle this. I don't know. I'm completely at a loss. I have no clue for this one. So we have a node, right? And we have cam on, it's going to be boolean value, and monitored, it's going to be boolean value, and we're going to return an integer, right? So I'm going to say, your cache max size equals none. Okay, so that's that, and then we can pass. So eventually what we're going to do is we're going to call dfs root camera on, of course this will be on, or dfs camera off, and of course it's now being monitored. Right. And then we need to return the minimum between these two. Okay. So we say if not node left and not node right. So this is the leaf. If I'm the leaf, then I say if camera is on, right, then we return 1. If camera off, if camera on or not camera on and not monitored, then we always return 1. Then like I have to turn my camera on, right? I have to turn my camera on. But hold on, what do you mean? So when I pass this, we say you are not monitored, right? I pass you a state is, if you are not monitored, how many do you need? And then come back, say, okay, I need 1. But when you need 1, you come back to me. What is my state? So it doesn't matter what my state is, right? No, like if my state is I don't have a camera and I'm off, then I will pass it down to you because I don't know. And I'm passing down to you, and you come back. Well, you need to tell me if your camera is on or not, right? So what we say, instead of just the integer, I need to also return whether the root of whether this one is on or off. So I return 2 values. Okay. So you say I return an integer, which is the number of count, and then a Boolean value if I am on. So I say if camera on, then I return 1 and true, right? If camera is off, right? Camera is off, then I say if monitored. So camera off. So my camera is off, but I'm being monitored. So I say, okay, for me, I don't have to return anything, then I'm not. Else, camera off, and I'm not being monitored, so I return 1 and true. Okay, so that's that. Now, for me, right? Then I need to pass down to my children, right? So I have a left subtree and a right subtree. So a left subtree I always pass, we can say camera on, then it will be monitored. Alright. Okay, again, so now I say if camera on. So my camera is on, right? Then when I pass the left subtree, I can do 2 things. Either camera on, so on the left subtree, so left count, first situation, left count cam is going to be DFS node.left. If my camera is on, and I can give the left camera is also on, and the monitor is on, right? And we can say left cam second situation, DFS. It can be false. Camera is false, but you also be monitored, right? And then this is just all the same for the right. right? So we say these two both can be right. Okay, now when we have all these situations, because on me, I'm already done, right? I know my camera is on. So all I have to do is just return, because my camera's on. All I need to find is the minimum. So we're just gonna be return the minimum of this plus minimum RC1 plus RC2, right? The minimum, but the minimum of the left condition, the minimum of the right condition, and then plus 1 because I have my camera on. So that's the total number, the minimum number I can return, and then return true because I have my camera on. Now else is if I am monitored. Okay, if I'm monitored, then it'll be the same thing, right? Doesn't matter. So I can say the left, I give a camera, or I don't give a camera. But if I don't give a camera, this is going to be false, right? If I don't give a camera, it's going to be false. And also in this case, none of these matters. I can just underscore because I have my camera on, so it doesn't really matter. But in here, that's going to be false, right? It's going to be false. Okay, so now we have to decide, all right? Oh, we'll see cam 1, cam 2, cam 1, cam 2, right? Oh, and oh man. If it's none, so if not node, and return 0. There's no camera, and it's also not on. Okay, so how do we do this? I have to, so basically I'll say on the left side, we may have two situations. On the right side, I have two situations. And the left side, we have 4 combinations, right? LC1, RC1, LC1, RC2. So basically, we need to find a minimum that representing us. Then we say, okay, I'm going to take LC1 and RC1, okay? So in this case, we say, oh, because I am monitored, right? If I am monitored, then I don't really care. So if camera on, all monitored, if I'm already monitored, then I don't really give a damn, right? They can do whatever they want, and they have it, doesn't have it, doesn't matter. All I want is just find a minimum of the left, and then else. I don't have camera, and I'm also not monitored. This is the real thing. So, okay, I don't have a camera. So now we're gonna say, okay, if we're gonna do LC1, so we say situation 1, right? So count 1 is, okay, so L1 R1 L1 R1 in this situation, right, is going to be LC1 plus RC1, right, plus, because I'm not monitored, right? So if both, so we say LC cam1 or RC cam1, so any one of them is true, right? So we can actually integer this. I'm not sure if I can integer this, but I think I can. Let's say if A equals true, int A. Yeah, I can int. I'm just be more explicit, right? So I can say int this. Oh. L1 R1 cam. In this situation, the camera. Do I have a camera? That's gonna be not. Alright? Which means if one of them is true, then it becomes false. Right? If both are false, then it becomes true. Then this is gonna be if it's false, right? So if this is false, which means one of these is true, so that's going to be 0. I don't have it. Otherwise, yeah, so we have this. We basically do the same thing, right? We need to return the minimum. What if the minimum is the same? We have two situations and the minimum is the same. It's saying if we have the camera or we don't have the camera, that's the same. Oh God, how am I gonna deal with that? Yeah, how am I gonna deal with that if it's gonna be the same? No, I don't know. I'm giving up. It's too late. Let's see, the previous. I was able to do it by myself. What the heck? I'm not able to do it today. What? God. I have to keep thinking. I did it last time. It can't be. It can't be that hard. Come on. Don't know. The brain has been mushy right now, and this doesn't look right. This doesn't look right at all. Alright, I'm still gonna call it. The hell? Solved it last time, wasn't able to solve it this time. Jeez. I'm getting there. It's 3 states. So it is. I am having 3 states right here. So maybe we are on the right path. But my thing is, given all these states, what if I have these 3 values is the same? That's what troubles me, you know? That's what troubles me. What if they're the same? Or we can say, if they're the same, then we always return the one that with this one set to true. Okay. Now that I saw just a glimpse, so we can just do this, do this, do this. So 4 different situations, right? So we have this, and we have so it should be R2, right? L1 R2, L1 R2, and L2 R1, L2 R1, L2 R1, L2 R1, L2 R1, and then both, so all the ones becomes 2. So I have 4 situations. And then we just say we want the minimum, right? And we just say LR and cam. I don't know, math.inf cam, doesn't matter. Cam done equals false. Okay. And then we just say man, we can actually do it this way. Let's say no, I'll just do it this way. For PQ in, say, L1 R1 or we can just do the minimum. L1 R1 cam. Okay. 2, 3, 4. Right, so L1 R2, L2 R1, and then L2 R2. Okay. Say if L1, if PQ, if P is smaller than LR, is smaller equal to LR. If it's smaller than LR, then LR cam equals to P and Q. Now if P is equal to LR and Q is positive, then cam equals Q. Then I want to return LR and cam. sure. Well, this one is going to be 0. This one is going to be 0. It's ridiculous. I was able to solve it last time. Just can't do nothing. Don't know how. Oh, it didn't test the single node. Yeah, it's not right. Give up. It's too late. I don't even want to read my original code. So no camera, no color. Yeah, I have these 3. And then what do we return? We return S0, S1, and S2. If no node 0, 0, I think this is 0 and then 2. There's no camera, no footage. No camera, no coverage. No camera with coverage. And then with camera. It's the number of so it's the same idea, right? We have the same idea, but we have this small gaudy monstrosity here. Okay, we just change the idea. So instead of return this, what we're doing is when we DFS, we want to return in this node have 3 different states, and for each state, what is the minimum? So instead of passing 3 different states, we are going to return a list of integers. Well, mind you, I didn't really check it very carefully, so let's just do this. So when I pass this node, right, I'm going to return a list. So if it's empty, right, so we have 3 states. Okay, so the return value, actually it's not here, it's here. So the return value is say C1, C0, C1, and C2. And C0 is the count, is a minimum count of camera when a node has no camera and has no camera. C1 is the main count of camera of the subtree. When node has no camera but coverage. And C2 is the mean count of cameras of the subtree when node has camera. Yeah, we're almost there, but yeah, today is can do. So if we have no camera, and that's going to be 0. And with no camera, that's a 0. If we have camera, right, the node has camera, but we cannot have camera. So we cannot have camera. And we try to have a camera. We don't know, right? In the moment, I don't know. Otherwise, I call left, I call right, okay? And then give me these values. Now what? Now what? So on the left, if I have no camera, but no camera, but with coverage. And if the right is also. So are we matching them? It looks like we're matching them. And I want to find a minimum. Find a minimum under these three situations. Okay, so find a minimum so it has no camera and no coverage. Okay, so it's no camera and no coverage. Right, so let's say I have no camera and no coverage. Okay, I have no camera and no coverage. So if I am no camera, no coverage, then the child can only have C0 or C2, right? Because the child, if I have no camera, like the situation, I have no camera, no coverage, like I have no camera, then the child either is no camera, no coverage, or it has camera, right? That's the only thing. So we just need to find, let's say L and R is equal to DFS, no dot left, DFS, no dot right. Okay. Now, if the child, so we can't just say res equal to 0, 0, what? Well, what is that? We can just say R0, okay, C0, count 0. It shall equal to a minimum of L0 and L2 plus minimum of R0 and R2, right? Because if I have no camera, regardless of coverage or no coverage, then my child will never have coverage. So it's either 0 or 2. I will return the smaller of the two, return the smaller of the two, but because I don't have coverage. Ooh, but if they have camera, yeah, how do we handle that? It shall be. Isn't that going to be a miss and match if it's C0? Then we have the same situation I have right now, right? We have the match. It could be my left subtree can be no camera and no camera. My right can be has camera, that I don't need to have a camera. Right? It's those four situations. How do we do this? Minimum of this, this. Hold on. 0 is minimum of hold on. I have no coverage. C0 is I don't have coverage. So it's this situation, no camera and no coverage. Right? No camera and no coverage. Which means, what doesn't that mean it has to be, oh my god, it's no camera, no coverage. If I have no camera and no coverage, that's not I have, it's like I want to return a situation where if I have no camera and no coverage, what is the minimum number of cameras? That starting with, and if I start with no camera and no coverage, I don't understand. It's 0. It's 2. I understand this, right? If I have a camera, then it's just gonna be this. It makes sense. If I have no camera, but I have coverage, then the child is gonna be either, because I have no camera, so the child will be no coverage, or the child will have a camera. That makes sense. This is the thing that doesn't make sense to me. So I have no camera, and I'm not covered. And we go to the child. Then the child must have a camera. Oh, that's the final state. That's not the final state. That's the state I start with. So in order, because the state to start with is the parent has no camera and the parent has no coverage. And the child, we need to create, from the child, we need to create a state that can give the parent the coverage. So what I was thinking, which is not correct, what I was thinking is I want to put a camera into the parent if the child, both child has no camera. That's not right. That's not right. What we need to do is if I start with no camera and no coverage, right? That's the starting state, is I don't have a camera and I'm not covered. I'm not covered by my parent, right? It's the parent's parent. That's the state is if I'm not covered by my parent's parent, then I must be covered. So if I'm counting in this, then I must be covered by my child. So my child must have a camera, right? So my child must have a camera. So it can be L2, the left has a camera, and the right doesn't have to have a camera. So it's going to be this and this. The right does not need to have a camera. But in fact, the right can have a camera because it doesn't matter, right? So it's just the minimum of this, or the right must have a camera, and the left doesn't really matter, right? And the C1 is I have no camera, but I'm covered. Now in that case, it's, the left is going to be left 1 or left 2, because I'm either, the child either state is no camera but is covered. Nope. So my state is no camera but coverage. So my child doesn't need to bring a camera. So it should be either no camera, no coverage. Yeah, it's no camera or no coverage, or it has a camera. So yeah, so it should be this. No camera, no coverage. If no camera, no coverage is fine. It's no camera but coverage, right? So that's, but because my child cannot have courage because the parent doesn't have courage. Right? The parent has no camera. But what this is the child is not obliged to provide a camera. So I don't have to make the child provide a camera. All the child needs to do is anything, right? It doesn't really matter. So the child can either have a camera or no camera and no courage. It's just one thing the child cannot do is no camera but courage, right? Because it doesn't have courage from the parent. So from its parent. It's very important. It's from its parent. Okay, so in this, minimum of this plus minimum of R, 0 and R2. And C2 is, I have camera, so my child, if it's nose, I have to have coverage, or they can have a camera. R1, R2. Okay. Now we don't have to do any one of this. We just need to return. This, and this. That's it. Alright, so now we have to answer this question. What should I do? Yeah, it's going to be math.inf because we want this one to take 0. When you compare L2, we want to take 0. So we're going to pass DFS, right? I'm going to say DFS root is 0 because I have no coverage. Rest 2. I have the idea of creating 3 states, but got confused about where the 3 states are applied. They should be applied in the return value. But my earlier attempt was trying to apply them at the start, which I think it might work, but honestly, I don't need to cache this because each is only going to be called once. I have no clue why it's just so bad, right? Lately, just hit a big low and everything. Oh my god, this is not right. What? This is not right. Oh, should be +1 because this one has camera. Yeah, so this is the state where, yeah, this is the state. This state must add nodes cam. I don't know. It's just, it got so bad. Oh, wait. I thought we're done. What? I think this is not R, huh? So I'm still not truly understand this. Okay, so this state is I must have no camera, right? Then if this has a camera, then I say I don't want this one to have camera. But what's the difference? Like, seriously, what the hell is the difference? What the hell is the difference? I think that's the only difference between this one and the previous one, right? Oh man. Yeah. I do 0 and 2. I cannot do 1. Oh shoot, you are right. I cannot do 1. Because 1 is no camera but coverage. But this one is C0 has no camera. Oh yeah, it's correct. I just realized if you ask me to solve one of those stock buying and selling problem, I probably cannot do it now. The head is just not in the right place. The head is just not in the right place. Damn. Oh, this is probably the worst couple of days. Getting worse and worse every single day. Cannot include L1 and R1 because the children cannot have coverage when the node, right? When the node does not have camera and must add 1 because the node must have camera. Man, it's so bad. It's so bad. Alright, let's see if we can turn around tomorrow. Man, I'll see you guys tomorrow. Adios.